Okay, welcome to part 3, which will hopefully be the final part of this series. In this video we're going to finish off the terrain generator and also add a populator to grow trees in the world. So, what we need to do first, like I mentioned at the end of the previous part, is instead of just setting the bottom layer to bedrock, we need to set the bottom layer to bedrock still, and the 19 layers above that to dirt, and then the one above that to grass. So the way we do that is by using a for loop here. So we're going to loop upwards from y equals 1 up to y equals 19, setting dirt, and then we're going to set y equals 20 to grass. So the way we do that is just by using another for loop. So for y equals 0, while y is less than 20, increment y. And then here we just need to set some blocks. So we're going to copy this line, paste it here. Obviously x is x still, z is z still, but 0 now should be y, because we're using the y variable from here. That should actually be y equals 1, sorry about that. And then the material is no longer bedrock, it's now dirt. Lovely dirt. And paste that again below it to set the 20th block to grass. The reason we don't set all these to grass, I'm not sure if I mentioned it earlier, is that when the game loads, all the grass below the dirt, below the top layer, will convert to dirt, and it takes forever, causes quite a lot of lag, quite a lot of physics events going on there, so that's something to avoid. Not physics events, block changes, not a good idea. So once we've done that, we can basically test this out. So if I just export this plugin again and click finish, and we need to remove our flat world, because when you've created a world with multiverse, and say you delete its world folder like so, and then you start the server up, it will generate that world again, which is quite a nice way for testing. So say you want to regenerate a world, you can just delete its folder and then start up the server. Ooh, okay, maybe I shouldn't have done that while the server was loaded. So let's just make sure it's still deleted. Yep, so we can start the server up now, and it should generate the world. So it looks like it has. So if we go to our server and log in, our game, sorry, you can see that now we have grass pretty much in every direction. And I'm in creative mode, so if I just fly up into the air, you can see that basically, we just have grass in every direction. I'm actually going over here because there's none over here. This is one massive biome, and there's some wolves. Yeah. What I want to show you is that biomes are still present. So if I just go this direction, you can see that the grass colour changes here, and this is because this is a different biome. So when you're populating stuff like trees, you can still check the biome to see what type of tree you want to grow. So say you wanted to grow trees, or you wanted to add snow in a whatever biome that's meant to have snow, tundra is it? You could do that. And also something else I thought was quite interesting is, I don't know if you know, but Notch posted that biome code is now fractal based. If you fly up and look down at the grass, that you can see sort of the fractal pattern ever so slightly. And also interesting is that when you get to a certain height, the void turns black, which is a little bit weird, but fine, no problem there. So that's basically that, and the next thing we need to do is add a populator to add trees. So like I said earlier, populators are called after generators. So they work in a completely different way. They work in the same way essentially as just setting a block in the normal code basically. So if you remember in the previous video, we set the block of place TNT to cake. You basically do it the same way here. You just use the set type method. Or you can use functions to grow a tree, which are provided by the server, which is what we're going to be doing. But I'll demonstrate with set block first. So the way what we need to do is add a populator to our list of populators here. So instead of just returning the empty array list, we're going to create a new variable whose type is going to be basically this. So I'll just copy that and paste it there. Its name is going to be populators, and it's going to be equal to that new array list. And then we need to add something to this list, so we're going to use populators. That's obviously wrong. Add, and what we're going to be adding is a new instance of our populator. which doesn't actually exist yet, but we're going to create it. We're going to create it in a moment, and it's going to be a new class which is going to have the name Flatlands Tree Populator. Okay, so that's that. It's not going to take any parameters, so we're just going to do that. And then we need to return this list of populators because, well, we need to return the list. So we just do return populators, like so. And obviously this class doesn't exist, so we need to go ahead and create it. So I'm going to just right click on the package here, go to new class, and then bring this down, and we need to name it. The name is Flatlands Tree Populator. Populator. Hit enter, and you can see we have this new class created. And as the ChunkGenerator class that we wrote here extended the ChunkGenerator, this populator class needs to extend the populator class. So we just do extends BlockPopulator, like so. And this will need importing. Import. And now you can see that this has gone red underlined, and that's because there are unimplemented methods. So we just need to add the unimplemented methods, and that creates this for us. It doesn't need to override anything, so we can remove that, and this comment is pretty useless too. So this method here, populate, is called essentially after the generate. So for every new chunk that is created, this generate method will be called, which will create, you know, the actual structure of the trunk of the chunk, and then after that, this populate function will be called, passing in the chunk as this parameter here. So these parameters obviously need to be renamed because arg0, 1 and 2 is not very friendly. So instead of arg0 for the world parameter, I'm going to change it to world. Instead of random for the random parameter, I'm going to change it to random, like so. And instead of chunk, we're going to change it to chunk. So say we wanted to just set, well, you can just set blocks, and also you can use methods that would not be available at the chunk generation stage, like the growing trees method, which I'll get to soon. So just as an example though, say we wanted to set a block in the middle of the chunk. We can get the block in the middle of the chunk at y equals 21 by doing chunk get block at, which is oh sorry, no, it's not get block at, it's just get block. This takes 3 parameters, which is x, y and z. So x would be 8 for the middle, y would be 21 for the height that we want, because we did a grass up to 20, and 8 for the z as well. So what we can do is then use that block to set, well, we can set the type of that block, for example, to material fire. Why not? Let's just hide these imports. There we go. So if we run our generator now, we should get fire every sort of 16 blocks in all directions, in the middle of every chunk basically. So what we can do is, well, we can test this. So we can just export our plugin, just hit finish, ignore that warning, and hopefully, yep, we need to delete the flat folder again, and ooh, I did it again. And start up the server, and then we can join the server. End of stream. Try again. There we go. And hopefully I won't spawn in the fire. Nope. And as you can see, if I just fly up, what we have is basically what I just described. We have fire generated in every direction, every 16 blocks, except this one that just went out, and that one, and all those. So that is pretty much it really for that. Well, as for block populators. Ooh. Oh. Don't know why I did that. Kaboom. So, what we're going to do next is, instead of setting each block to fire, we're going to grow a tree at this location. So the way we do that, if we just stop the server before I forget and delete the world again, the way we do that is using a method provided by the world. So we can delete that entirely, and what we do is world, hang on, world, yeah, world generate tree. which takes two parameters, the first being the location and the second being the type of the tree. Now the location is actually a little bit awkward because we can't get the location of a block in the chunk without actually getting the block, which is, that's fine, you can do that. So say we wanted to get the location of that block that I just set the fire to, we would have to do chunk get block 8 21 8, then we'd have to do get location, which is fine. I mean, you can do that. That would be acceptable if you want to work in the chunk coordinates. Also, you could optionally get the world coordinates of this chunk, because each chunk has its own set of coordinates. So that would be 1, 2, 3, up to however many chunks you've got. And these are basically the world coordinates divided by 16. So to get the coordinate of in the world of the chunk, you have to do the chunk coordinate times 16. So say you wanted to get the x coordinate in world coordinates of the chunk, you'd do int, well, you'd set the variable, so int type world x equals chunk get x times 16, like so. And the same for z, except get x would be get z. So you do int world z equals chunk get z times 16. So whichever of these methods is sort of most suitable, really. So say if you're working with something that goes across multiple chunks, using the world coordinates would probably be more suitable. But for this, we can actually use this method here of getting a block and then getting its location, because well, working in chunk coordinates is still a bit easier, because really we're still dealing with individual chunks. We're not actually dealing with sort of overall structures that span multiple chunks. So yeah, that's pretty much that. So that's just sort of two alternative ways of doing it. So what you do then is world get block at, and then use these coordinates. But this method works fine just as well. So we don't actually need those. So the tree type is the next thing we need to deal with, which is provided by the tree type class, and then you just set the type like so. So say you wanted to just tree. It's weird, quite odd actually, because tree type tree is just a standard tree, which I think they go up to the small tree that you can chop down easily. So we can just demonstrate that actually. So if we just run this code now, if we export it and ignore that, and then delete our world, and then start the server, and then join the server, what you should see is trees in every direction. Yep. So if I just fly into the air a little bit, you can see that we have trees in the middle of every chunk, pretty much in infinite every direction, which looks quite strange, to be honest. In fact, the game doesn't seem to like it very much, because it sort of loads train in weird order. But basically what we have is trees separated by 16 blocks. So that was 16 blocks, if I clicked properly. Obviously this doesn't look very natural, so the next thing we're going to add to this is only generating trees in the middle of a chunk with 10% probability. So let's just land and disconnect and go back to our code. First stop the server. So to add a sort of probability of generating a tree, we just need to use the random number thing provided. So to generate a random number from this random object, well, actually a random object is already essentially a list of random numbers, and the only you don't generate them, you get the next one, if that makes more sense. So it's always going to be the same number whenever you use the same seed. So say to give something a 10% chance of happening, what you can do is use an if statement like so. So if random next int takes one parameter, which is the maximum value for the number. So say if you passed in 100 here, it would generate a random number between 0 and 100 inclusive. And say you want to if then you check if that is less than or equal to 10, that will give you a 10% chance of this if statement being true, because if you generate a random number between 0 and 100, and then check if it's less than 10. There's only a 10% chance of that happening. So now what we should have is only 10% of the trees that we had previously. So let's export this and test it out again. Actually, I did say previously that we were going to use this plugin which is causing all these problems. We didn't actually ever use that. It may be useful in the future if you want to log errors, actually. So instead of having to click OK on those warnings all the time, what you can do is just hover over it, and you can do this bottom one, add suppress warning unused. So if you just click that, that appears, then you won't get that warning anymore. So there's a useful tip if you plan to use something but don't need to at the moment, and for whatever reason you want to leave it in. In this case it's because I'm lazy. Anyway, so let's just export this one more time. See no more. Oh, okay, there was a warning. Oh right, I've got an unused import now. So if we delete that unused import and export it for one final time, no warnings. So just make sure the flat folder is deleted and start up the server, and then we can go and join the game. We should now see a lot less trees, which we do. So now you can see that we have trees sort of in a more natural looking pattern, although if I just come over here where there are quite a few, or well here, if I just stand here, you can see that they are all in perfect alignment, which is obviously something that isn't very natural. So to add even more sort of naturalness, what we can do is sort of offset their position by a random amount. So we can offset it by like -3 or +3 in both directions, which is what we're going to do next. So just disconnect and go back to our code. So what we want to do here is just stop the server before I forget. What we want to do here is basically try and make this look a bit less programmed. So what we want to do is generate a tree between, let's say, between 6 and between 6 and 10. So that give it 4 in either direction that it could be in, which will just look a little bit more natural. So what we can do is replace this with 6 plus random next int 4, and then we could do the same here. 6 plus random next int 4. Okay, so that's that, and then we can just export this once more and delete our world folder, start up a server, have it regenerate the world, and go to the game and log in and fall to my almost death. Now if I just fly up again, let's see, here are two that would have previously been lined up, and now you can see that if I stand here they are not. So it just looks a little bit more natural. What we're trying to do is make it look as if it wasn't programmed, basically. So it's starting to look a little bit better. Obviously you don't really want this many trees because it's meant to be a free build world, or maybe you do, I don't know. You can obviously do whatever you like. So that is pretty much that. The next thing we're going to do is just change the, we're going to go over, hang on, what we're going to do? We're going to randomize the chance of each tree being big. So say, this is the tree type, the default standard tree type. You can also get large trees, the ones that are awkward to cut down. So I'll just stop the server, we'll do that. So going back to our code, what we need to do is give this tree type parameter at the end a random probability of being big tree. So what we're going to do is inside this block here, once we've decided that we do need to generate a tree, I'm going to define a new variable whose type is going to be tree type, and its name is just going to be type, and it's going to be equal to, and we're going to use the ternary operator here, and the condition is going to be this thing in brackets, which is going to be the probability test again. So we're going to use random next int 100, and if it's less than or equal to 30, so 30% chance, we're going to set type equal to tree type big tree. Otherwise we're going to set it to tree type tree, like so. And then here at the end we can use this this type variable just to determine the type. What this will do is make it so that 30% of the trees are big trees. Okay, so if we just export this for the hopefully final time and delete our world folder and start up the server and then wait for it to generate and join the game like so, you can now see that some of these trees are big like so. So about 30% of the trees should be large and the rest not, which again just looks a little bit more natural. That's sort of what you see in nature. Some trees are bigger than others, basically. Okay, so that is pretty much it, really. Is there anything else I need to mention? There is something else I need to mention. So when you use the block populator, you can set pretty much any block, really. Although if you set a block that isn't in a chunk that has been generated or isn't loaded, you won't get any errors, but neither will that block be set. It'll just come out as, you know, nothing. So say if you put these trees, instead of at the middle of the chunk, if you put them at the edge of the chunk, sometimes they'll have no half, they'll be like half a tree, because it's tried to set a block in a chunk that doesn't exist yet, and obviously that's not possible. So that's just something to think about, and that's basically why I put them in the middle. You can work around that. You can check to see if a chunk is generated and have it generate if it's not, but you need to be careful of that causing infinite generation. So say if you put a tree at the edge of every chunk and did that check, you'd cause infinite generation, which is not something you want to do. So anyway, that's pretty much it. This is what we've created. It's a flat, rather boring landscape, and in some of the upcoming upcoming series, I'll be dealing with how to generate hills, which is something you do to make it look a little bit more interesting, and that is a little bit more complicated, to be honest. Pigs, grr. So yeah, that's pretty much that. So thank you for watching, and hopefully this was useful, or if not, at least entertaining.